I would like to introduce for you this gentleman in the blue hat here. H on his hat stands for Hon02, which is his Twitter handle, and also Heroku, where he works. That's why he wears the hat, I'm pretty sure. I'm not a sports ball person, but I think that's what it is. So Terence actually and I have been friends for a reasonably long time. We met at the first Ruby on Rails, which I think was his first speaking gig, and I was impressed because he's a snappy desser like me, so we got along right away. He works at Heroku, as I've said. He also works on Ruby. He, I believe, is the only person to have ever maintained 2 Ruby versions at the same time, 187 and 192. May they rest in peace. And now
Zangief helped me.
Oh, and Zangief, yes. Everyone remembers Zangief from earlier, also helped with that. One of his early Ruby projects when he was fresh out of the bear wrestling mines of Siberia. So he and Terence worked on those Rubies together, and Terence now works at Heroku. If anyone has used Heroku, you have used Terence's code because he wrote the build packs and maintains the build packs. And I'm sure there is more to the build packs than just Terence's code, but he was instrumental, to say the least. So with no further ado, I want to mention one more thing, actually. Terence also started organizing a conference this last year held in Austin called Keep Ruby Weird. And Austin, for the record, stole the Keep Austin Weird from Portland. That was a Portland thing. Originally, we invented it because I said it on real video. Now it's known to everyone that Portland invented it and Austin stole it. And
you should probably update the Wikipedia article.
I'm going to go update Wikipedia after this. I got to go to Keep Ruby Weird this last year, and it is fantastic. It is a lovely conference. They have a mascot named Rhodey. Some of you got a preview of me sitting on Rhodey, the other slide. And if you get a chance, you should definitely go to Keep Ruby Weird. It's a lot of fun. Very similar feel to Ruby on Rails, actually. A lot of close people hanging out. So this is Terence. Big round of applause.
How do I do this?
Thanks, Paul.
Awesome. Yeah, so this is a picture of Jonan sitting on Rhodey during our socialization practices at Keep Ruby Weird. So this is my 3rd time speaking at Ruby on Rails, and I still get really nervous, so I asked Jonan for help, and he told me to put this slide in to make me feel a little better about it. So I'm here to talk to you about Ruby objects a little bit. When I think about Walkabout, I think of Australia, I guess. That's where it comes from. So this is me at RubyConf Australia. I don't really know what I'm doing, but I'm supposed to be doing a Friday hug. But I'm actually kind of disappointed the organizers didn't schedule me on Friday, because I've been able to do that the last 2 times. But I guess I'm going to hope Ernie's going to do it tomorrow morning for me. I am go by Hon02 on Twitter. Like Joan said, I come from Austin, Texas. We have really awesome tacos. Joan will vouch for me. I picked him up at the airport when he came into town and took him to some pretty awesome tacos. We also have really good barbecue. I don't know if you've heard. So we took a bunch of the speakers to Franklin Barbecue, which is this really famous barbecue place in Austin. And this is a picture of Jonan not getting into the barbecue place because it's like a 5-hour wait to get in. And this is a picture of the barbecue. But we did eventually let him in to have some barbecue. And like Joan said, I have a blue hat. I don't really know why I'm known for it. I guess I just wear it all the time. And it does not stand for Heroku or Hon02. It's actually just a college hat, but they don't sell it anymore. And you're probably going to ask me what I'm going to do when I lose this hat. I don't have a real answer. But I do have hat stickers, some of them left. So if you do want a hat sticker, feel free to come up and just talk to me. And I'd be more than happy to give you some if I have any left. I work at Heroku. Happy to have been there. Been there for almost 5 years at this point, and they let me work on open source and a bunch of Ruby stuff, maintaining Ruby 197, 192 with Zach, and work on some of the bundler stuff and a lot of other things. So I'm super appreciative of our customers and the chance to be able to do all that stuff. So if there's anything actually broken on Heroku related to Ruby, that is my fault, so you can come yell at me about that. And one of the awesome things is I get to work with this guy, Richard Schneeman. I don't know if you've heard of him, but he's done a bunch of stuff. He just got commit to Rails recently, and super. He just passed his 3 years at Heroku, so super happy to work with him. And if you didn't know, Ruby Heroes vote ends in 4 days, so you should go vote for him for all the work that he's done. I think he's done a patch to Rack that has improved memory consumption by 5% across all Rack apps out there, so just one of the many things he does. In addition, you should vote for Zangief as well. I told him I'd be his Ruby Hero campaign manager over the last year, so in every talk that I've given since 2013, I've included this slide of him for, all the work he's done in MRuby, but also maintaining Ruby Doc and many other things. I know he spends many nights and weekends working on stuff, so we don't have to. But on to my actual talk. I've heard a lot of Ruby talks about introspecting and doing things in Ruby. Davey's given an awesome talk about benchmarking, and one of my good friends just benchmarks everything against the Fibonacci algorithm. But I'm not here to talk to you about Fibonacci or benchmarking. I used to do some Java development, and I've done some stuff with JRuby, and I'm super jealous of their tooling that they have, the enterprise tools that they have. But you can get these cool graphs of stuff running in production. You can dump like your thread stack and stuff and like load it up in another process from production. And I kind of want to explore and talk about some of the tools that we have in Ruby that aren't quite there, but that are getting us towards something that is better of what you can do with your Ruby applications. So I'm here to talk to you about TracePoint, ObjectSpace, and the allocation tracer gem. Basically, Kira came and talked to me and said I'm giving the Koichi talk, so I'm here to talk about all the work that he's done. So on to TracePoint. So before TracePoint came out in Ruby 2.0, but before that, we had kernel set trace func, which was a method on top of kernel, and basically you can set a set trace func and then pass it this proc, and then you get these parameters that you can use and basically print out some information. So you have this event. You can look at the file, which is the file from the source file, what line it is in that source file, the ID, which is the class, or no, not the class, the method, the binding in the class. And so here is some example code, just really, really basic, simple stuff, right? Have a class foo, has a single method, instantiate, print it out. And so we've instantiated trace, we have some code we want to trace, and then we can disable the trace at the end, so when we run foo.new, it won't get traced anymore. So this is an example of how we use, how to do any of this tracing stuff before Ruby 2.0. And when you run this, you get some output like this. And so we can see the first line is that set trace func from the beginning, up top there. And so it's just running this printf here. And then we can see that an event gets called for the class, and there's that class being instantiated. We have the method that's being added, and then we see the method being instantiated there. This is that, and then we have the new class that's being instantiated below the actual describing of the class, and we see that in foo.new. And then when we call bar, we see that output there. And so we're calling bar there, and then we're basically disabling the trace, and that's the end of it. So we don't see this foo.new at the end. And basically, when you instantiate set trace func, it gets run on every single event that is here. So this is every C call, and then the return of all those methods. When you do a Ruby call and a return, when you start and end a new class, for every single line in the Ruby code and every time you raise. So you can imagine actually calling this and setting this stuff in production would be really slow because you're essentially running that set trace func proc every time. So, but like if you're trying to debug something because of some memory leak or something, you're trying to introspect like what the heck is Rails doing that I don't understand outside of production, this is a good way to get some more information about that. So Ruby 2.0 came along and TracePoint was introduced. So we have the TracePoint API. And one of the great things about this is it added even some more methods. So we have bcall, and so B is for block. So for every block, for every call and return that, we get an event called. And then also stuff for threads. So when you get a thread begin and when threads end, this will be instantiated. But one of the nice things is it's actually object-oriented, so this is a way we would do that exact code from before, but using TracePoint. So we instantiate a new TracePoint object, and then on here we can actually if we were to mimic the exact same stuff from before, this is how you would do that. And then you just pass it around a block, and then you can just have it run against that code, and then you get output that's basically the same, right? Except you don't have the set trace func at the beginning or end that has the enable or disable in this code. But one of the nice things here is that you can also limit it to specific event calls, which you can't do in set trace func. So you can have TracePoint actually only get called for specific events. So you don't have to do an if statement inside of your proc object. So Matt Eminetti, after TracePoint came out, actually wrote this middleware. So I stole this from this gist that he had on his blog and basically turned it into a gem so I could pull it into my rack applications to kind of introspect and see stuff in there. So basically all it does is it goes through and counts the number of classes that are created, the number of methods that are created, and then the number of methods that are dispatched. And I kind of just wanted to compare what that would look like across like a simple rack app, a simple Sinatra app, and a simple Rails app that had very similar code. So here's that TracePoint middleware. It does a bunch of stuff. If you go to this gist, you can see the actual code. And then here's my simple rack app, and I'm basically just requiring it right before and then using it. And then all I'm trying to do here is print the Ruby version out. And how many methods or classes do you think this actually calls? 500. So someone said 500. 5,000. Over 9,000. So like JRuby 9,000. So this actually only calls it instantiates one class, the one we defined, calls one method, has one method that's called, and dispatches that single method. So I did the same thing for Sinatra, like very simple hello world, pretty much the same thing. How many classes and methods do you think are on this? 37. 37 classes, 37 all around. 5,000. So this is actually, just to do a hello world Sinatra app, is 43 classes, there are 155 methods used, and then 548 method calls are actually dispatched. So like it's way more just to even get like a hello world Sinatra app. But of course the fun one is when you get to Rails, right? So this is my very simple Rails like hello world that I tried to mimic the same thing. So we have a very simple like view and controller. How many classes and methods do you think this is? 370,000. Wow. I don't think I'm running that version of Rails. So the answer is 361 classes, almost 1,200 methods are instantiated, and then 8,600 methods are dispatched. And so this is basically an order of magnitude more than Sinatra, right? Like 43 versus this. But this is just an example of like cool things you can do with TracePoint. The fact that you can actually like have a method that's called on various points in your code. So just an example of, I didn't think this was particularly useful besides just introspection, but like you can imagine building something that is much more useful based off of this TracePoint information. So in that TracePoint middleware, I also printed out a JSON of basically those classes and then all the methods that are called, and then how many times they're called, just to calculate like that summary information, right? You have to generate this hash anyways. And so I just saved this to a JSON file. And so here's an example of that output. And so for this Sinatra example, I basically sorted based on the number of times every method is dispatched. So E or B in Sinatra is the thing that is called basically the most when you're doing this Hello World Sinatra app, which I thought was just interesting. So based off this, potentially you could maybe optimize like certain calls or reduce methods that are being dispatched. But just, again, interesting information that you can introspect in your Ruby app, stuff that I haven't really dug into before until like the last year or so. So that is TracePoint. And so it allows you to essentially insert code that allows you to run stuff on lines inside of Ruby, right? Like when events are called. So the next thing I want to take a look at is ObjectSpace. And so ObjectSpace has an API. I think the first time it was introduced was in Ruby 1.9. I could be wrong about that. And then there was the .so that was added later. But they've been slowly adding more and more stuff into the API. And so you can do count objects, which will give you the count of the various objects inside of Ruby, which can be interesting to look at when you're trying to analyze like object counting or memory information. You can iterate through the whole graph and kind of walk through every single object. So this was just code I wrote. I wanted to boot up a simple Ruby application that really didn't have anything, and then basically require JSON and see like how much stuff is there in this thing. And so I'm using each object to count through the objects and then sorting them. And as you can see, like when you're using JSON, like you're getting a ton of strings like being pulled in, right? So again, just interesting information of like the kind of objects that are being instantiated and the counts and things you can do with really basic stuff inside ObjectSpace. Like this code is not very complicated. But again, to note, like if you're walking through the whole object graph on a real application production, that's going to be a really expensive hit. So don't like litter this code in your production. So there's a C extension that is part of the standard library called ObjectSpace SO that gives you access to more stuff. And one of the main things that's in there is the allocation tracer. And so allows us to do stuff that is similar to TracePoint. So if we require object space up top, this actually requires the .so file. And then we can again wrap this, we can call trace object allocations and then wrap this around code we want to trace. So when we start trace object allocations, it is doing a bunch of work behind the scenes. So again, it's going to slow your code down, but it allows you to examine a bunch of things. So this is another alternative way to kind of look at similar information that you would get from TracePoint, but just using object space. So in here, I'm looking at the source file, I'm looking at the source line, the method that is actually being called, and then I want to look at the class path, the class name of what's actually being used here. So given this, this is the output that's just returned for that same thing. So we're not getting all of the class inheritance thing. We're just seeing like the object being counted here. But when you start using this stuff, you can actually start counting objects. So I started just going through and building a simple thing that would just walk through each of the objects and kind of count how much space is being consumed. And this is just like a really short example. So creating a struct to kind of hold all this information, and then I'm defining a method that is going to walk through each of the objects and then essentially store that information in a struct and then use it later. So analyzing that same code or a similar code and then walking over it, and then we want to then sort it, and we see that for each of these we can see where in each line in the source file it is, what the method on the class is, and how many bytes is being consumed. So this Memsize of in object space is a rough estimate, so it's not an exact count of the objects that are being used there. So I know Sam Saffron did a bunch of work, and he does something similar, but does a lot more other things inside his memory profiler gem. So you can go through and run this. And when I was talking about Richard and his work before, he actually went and ran memory profiler on some stuff in rack, and that's how he found all these string objects being allocated. And so there was a patch that he made to rack where he looked at basically these strings and constantized some of them, and it gave basically a 5% memory savings just by doing that work, by reducing the number of string allocations being done. So this is stuff that you can definitely do in your current application to actually do memory savings and see like where you're leaking objects or creating a lot of objects that you might not actually be aware of. So the next part of this is the allocation tracer gem. And so this is a gem that my coworker Koichi made. And this is built off of a bunch of stuff inside of the ObjectSpace API, but kind of wraps some nice things around it. And so you have to gem install it because it's a gem, or add it to your gem file. And then I made up some algorithm to kind of analyze like the object allocation in it, so we can actually have some data to play with. So this simple algorithm, I think we create a pivot that is halfway through, and we're basically like swapping elements from the beginning and end of the array. Pretty simple. And then we have some large array that we're passing through to this method. So ObjectSpace allocation tracer is off of ObjectSpace, and basically like a similar pattern. You're just calling trace on in the code block that you want to analyze. If you call trace without a block, it will just start, and then at the end you can basically disable it as well. So we're just wrapping this around the code that we're doing, and this is the output that we get. So just to kind of quickly walk through all the things that we're returning here, you get the file name, the number, which you should be used to seeing at this point. And this first number is actually the number of objects being allocated on that line. So this is all the objects that are being created for this specific line, which is actually pretty interesting information. So if we look at this code from before, this is every single line and where every object's actually being allocated. So pretty interesting information. In Ruby 2.1, we have the garbage collector that moves stuff into old objects, the generational GC. And so this actually tells you the number of objects that are promoted from new gen to old gen. So it helps you analyze some of the work that the garbage collector is doing. This gives you the age of all the objects at that point in the source line. This tells you the minimum age of all the objects, and then you have the maximum age. And then you have some Memsize without the RVALUE. And so this basically, RVALUE is basically like all the Ruby objects that you're creating. So like you have RArray, RString, and stuff like that. So it doesn't include any of those things. But I'm not going to go into too much detail into that. Pat Shaughnessy, if you search, has an article that talks about some of the stuff when he talks about the whole like string and 23 characters long and why that's optimized and whatnot, and he goes into that a little bit more. Yeah, and he also has that great book, Ruby Under the Microscope, as well. I would recommend anyone who's interested in internals to go and read that. So if we go and like look at the output now that we know what each of these columns actually mean, we see on line 15 here that we're creating 10,004 objects. And that seems like kind of on par of like what we're seeing here. We set n to 10,000, but there's like these 4 extra objects that we're creating, and we don't really know off the top, like at least I don't really know off the top of my head, like what those are, what's actually being created. And then we also have on line 7 here, which is this multi-assignment. Like we have 5,000 objects being created, and that's like I guess like I'm somewhat surprised by that, but you know, like n is 10,000, so I guess like on each assignment it's creating some type of object for each iteration through that loop. And we can, to kind of dig into more information, object allocation tracer allows you to actually set up the keys that you get in the beginning. And so we have the path in line, which is what we're already doing, and you actually can pass in type, which allows you to break it down to, it will separate into each type that's being created. So if we run through this code, we actually get this output. So it actually splits it out into, so we have more lines than before because it splits it out into each type, and because that's what we're keying off of. So from before, we had those 10,004 objects, but now we see we're splitting up into, we have a node type, so a data type, we're getting an array, and then the 10,000 strings, which makes sense because that's like the size of n. So you can kind of dig into that a little more. And the other thing that's really interesting here is that we have this array type. So we know that, now we know that on line 7 in that multi-assignment that we're actually creating 5,000 arrays, which is kind of surprising. Like that's not what I would think necessarily in that multi-assignment. So in that code, that's line 7. And if we actually change the code to this and we rerun allocation tracer and we print that out, we actually see that that disappears. So like you can definitely like analyze the code and try to optimize certain cases of like when you're doing object allocations that you might not be aware that you're actually doing. So I actually, like Koichi sent me notes about like this whole thing, and this was an algorithm that he sent to me like on like using allocation tracer and actually like seeing how it can be actually useful. So what happens here is that in the multi-assignment over here, we have, since we're multi-assigning inside of arrays on the left-hand side, like an index on the array, that is actually a method call, right? Like you can override the brackets, and that means in Ruby that there potentially can be side effects that happen. So inside of Ruby, that means that when we're doing this assignment, we have to create an array to store the values on the right before assigning them onto the left, because the execution order actually matters. If we were to actually just have like X and Y on the left-hand side, and we ran the same exact code, you would not see the array being allocated in the code. But since we're doing method calls on the left-hand side, we have to care about the actual assignment, which is why these arrays are being created. So if we uglify this a little bit and split this into 3 lines instead of that convenient 1-line method, we see that the actual objects for that array disappear. So that's an example of stuff you can do that's kind of neat with allocation tracer. You can definitely introspect into a bunch of things. The gem actually does a lot more things, but I didn't want to dive into too many things here into this talk. So I guess I ran through this really quickly. So in conclusion, we actually have a bunch of tools that we've been working on in Ruby core to help you analyze and debug your Ruby application. We understand that it's not as nice as like running something like JVisualVM, but we are working on hooks and things to help you introspect your application better. And if you have ideas or things that you actually need that you can't do right now, we're open to feedback on either working with you to add those hooks in or talking and discussing like what is your use case for doing that. So there are great tools out there in our ecosystem right now, like New Relic and Skylight and other things that allow you to analyze performance and other things in your application, but they don't really help you necessarily drill down all the way inside the actual Ruby code. They can help a ton with things like database queries and other things like that, but you definitely want to be able to dig out like these tools in your have these tools in your toolbox to basically run against your code to help introspect like parts where you're actually doing a lot of allocations or you're noticing a ton of that stuff. Because a ton of object allocations mean that you need to do more GC, which obviously slows down your app because you have to stop the world for MRI. And that's kind of all I had for my talk. Awesome. Well, I guess that means it's lunchtime.